Okay, this is an introduction for lab number 3, where we take a look at motion graphs, specifically position, velocity, and acceleration, and how they're related to one another. Now, something you should have remembered from the last lab is the slope of the position versus time is the velocity. So if I had a line that's kind of increasing like that with as close to a constant slope as I can draw it, constant slope means constant velocity within my ability to draw, and constant velocity means no acceleration. So this guy would look just like that. If I had something that was speeding up, it would be covering more and more and more ground as time went on, so it would look kind of like this. And you can see that this slope is going to be constantly increasing, and so the velocity would be constantly increasing. Now, it turns out that the slope of the velocity versus time is the acceleration. So if you look at the slope for this guy, it's positive and constant. And so this guy is going to be just kind of a constant positive acceleration, just like that. Now, we could be asking ourselves, what would happen if we were not speeding up, but we were slowing down? So let's go ahead and put slowing on here. What would happen is maybe I'm going to have some positive position right here, and it's going to kind of do one of those numbers, and maybe it even goes in the negative direction. We have positive directions and negative direction, and that really does kind of matter. Now what would happen is the velocity would be constantly decreasing, just like this, and it could even hit zero velocity, or it could hit negative velocity. This thing would have a constant slope or a constant negative acceleration like that. So the positive and negatives really kind of matter here. So we're going to come back and we're going to pop open the simulation, so I'll do that in just a second. And what we're going to do is we're going to go to the Charts tab, and we're going to first make a prediction of what you think the graphs would look like and explain your reasoning, and we're just going to give the man a constant velocity of negative 1 meter per second, and we're going to press play. So then what we're going to do is we're going to just kind of take a look at what the correct graphs should look like, and then what I want you to do, and very important, is in a different colored pen, write the correct graph, and I do expect them not to be the same for all of these guys. So here I've popped open the simulation, and it said to go to the Charts tab, and something else you definitely want to do is uncheck the sound. He makes a horrible sound when he hits that wall. And what we're going to do is I'm not going to give him the velocity of negative 1 meter per second because I want you to do the lab. I'm going to give him a velocity of positive 5 meters per second, and you can kind of see that boom, he goes up and he hits the wall. And we can zoom in and we can kind of see what the graphs kind of look like. You can kind of see just like that. We can clear all these guys, pause it and clear it, and we could just say give him an acceleration, and we could give him an acceleration of -3, and we can just go ahead and take a look at what these graphs look like. And again, what we can do is we can just use these guys right here to zoom in on these graphs and get a better feeling for it. So then all we're really doing is we're playing around with the simulation. So we're going to give him a speed of 1 meter per second, make a prediction, go ahead and in a different color pen sketch what the actual one looks like. We're going to come down, we're going to put him here, we're going to give him a speed, and that's pretty much what we're going to do for the rest of the lab. Please do use a different color pen to make your corrections, and we're going to just go through a couple of scenarios and take a look at what these graphs look like. And then what we're going to do is I have a scenario right here that I kind of messed around with, and kind of sketch what we would expect this to look like.